Hey guys, welcome back to episode number 18 of Omnifactory. And last time we got the ore processing set up. This has been running quite a while. I think it's actually out of ores. I might need to add some more to it, to the input. Yeah, but we're up to a lot of dusts in our system now. We have many of the things we need in order to progress. And I mentioned last time that we're going to start nuclear craft, which is what this is for. I'll show you that in a bit. But first, if we take a look at the quest book here, the next quests in order to make the reactor require these two platings, and this requires rare earth, which we get from redstone ore. We have a lot of this already, which gives us yttrium. So we have thousands of this dust. Barium, which we can get from barite, and barite comes from quartz ore. So I have set up this electrolyzer here for barite dust, give barium. And I think the only use for barium is to make yttrium barium cuperate dust. So I'm just exporting it straight into an autocrafter, providing the yttrium and copper dust to make yttrium barium cuperate dust. This dust we're going to have to blast furnace, which is one of the first things I'd like to do because this is also a very slow recipe. And I've also set up this electrolyzer for borax, and borax we get from salt. So we get this from rock salt and also regular salt. We can get a borax dust, and then we electrolyze this for boron. And the boron can be combined with steel to get ferroboron, and this is another component used a lot in nuclear craft for things like tough alloy, which is used for all of these components. Yeah, the basic plating uses this ferroboron, as well as coolers, machine chassis, yeah, things like that. So we're going to need that as well. So I think this step I'll just do on demand in our alloy smelter array, and combine that with steel as we need it. Alright, so let's add another blast furnace here for yttrium barium cuperate dust. There we go. And I actually forgot to put this into storage, so I'll have to extract this dust, and I'll probably just add another drawer here. That'll probably just be the easiest thing to do. Okay, so now this should be exposed to the ME system since I have a storage bus on here. We can add it to the interface in the input of the blast furnace. So we can add it here. We'll add our storage monitor and our level emitter and insert back to the interface. So we should be seeing... Wait, does this provide hot ingots or is it regular ingots? It is hot ingots, okay. And we're running this EV, so it is overclocked a little bit. It's still quite slow, but we don't need huge amounts of it at the moment. If we check the uses for yttrium barium, I think the only use is to make plating for nuclear craft, and it's also used in the wires somewhere. Yeah, it's used in LUV components. LUV. Yeah, basically all the LUV components use this as well. So we need a fair bit of it on hand, but we don't need it right now, so... And there's a quest. So I'll set the level emitter about 1000 for now. And don't forget the controller. So that's that taken care of. Let's check what else we need for nuclear craft. Alright, so ferroboron. This is boron plus steel. We can add a recipe for that. There's some just to complete the quest. The next one is tough alloy, which is ferroboron plus lithium. That's easy enough as well, actually. We can just input a recipe for that on demand. There we go, there's the tough alloy one encoded. We'll get some of that for the quest as well. There we go. So, basic platings. Steel heavy plating can be augmented with tungsten plates and tough alloy to make basic reactor plating. I think we can actually do all this already. We just have to put in the recipe for basic plating. So it's just a crafting recipe. We should have this from the microminers. And this will just go in our molecular assemblers. Let's just order a couple of that. Oh, tungsten plates we're missing. That's easy enough to add to our cutting machine array here. Actually, let's check how much tungsten we have now. Because remember, we're turning some of it into tungsten steel and some of it into tungsten carbide. But we're up to 898. That's a fair bit of it backlogged so far. I may actually just increase that up to even 1000. Yeah, let's just go for 1000 to keep backlogged. And we'll get some plating for the quest as well. There's the quest. The next step is advanced plating, which requires the yttrium barium cuperate plates. I think that's easy enough. That's just a cut and saw recipe. It also requires this hard carbon, which is graphite and diamond. We'll just add an alloy smelter recipe for that as well. And the recipe for the plates for yttrium barium cuperate. And we're missing graphite. How does it we get graphite again? Graphite dust. So is there a graphite ore? There must be a graphite ore. Oh yeah, we're at 450. We can add this to our ore processing now. So I'll add that here. That should all get processed. Then we can just encode that as a smelting pattern to get the ingots. And the first few just finished, so there's our advanced plating for the quest. And this unlocks the fusion reactor, or fission reactor. So I don't know exactly the way I'm going to set up the reactor, I'll have to figure that out here. But I do know that we're going to need to fuel it. And to fuel it, we have to get this Tbu fuel, which is what I've set up here. If we work backwards from the Tbu fuel, this comes from thorium-232, which comes from thermal centrifuging thorium dust. And we get this by pulverizing granite. Yeah, here, we can pulverize just vanilla granite blocks to get thorium and also black granite. Black granite, as the byproduct, can give us biotite, which can be turned into fluorine later on, which we'll need. But we're really after this thorium. Again, it's going to be used for Tbu fuel, and this is fuel for the first reactor. And then once you run this through the reactor, it gives you depleted fuel, and then you centrifuge this for the next tier. I haven't quite figured all this out. Like there's a whole recipe tree for the ones you want to process and craft into the next tier. So yeah, we're going to figure that out here and then build a reactor around that. I just wanted to get this Tbu going. So the way I have this set up is I'm using igneous extruders to make granite, and then I'm using IV macerators to turn that into thorium. I just had to disable the overclocks here, but if I turn this on, it's pretty fast. Like, yeah, we get tons and tons of thorium. Anyways, that all goes into drawer controllers and drawer slaves, just auto output. And then that's put into these drawers for black granite and thorium. And then it gets distributed into MV thermal centrifuges. The reason I'm using NV is because this recipe is a really poor overclock because it's 48 EU a tick. So using really anything above MV is a huge energy investment for not as much time reduction. And MV machines at this point are basically free. Well, that's the HV one, but yeah, the MV ones are basically free at this point. It really doesn't cost anything to produce these. So I made 32 to begin with. We might have to increase this as our thorium usage goes up. So yeah, that's what this setup is for. And then I was thinking we build our reactor in this space here, or at least the first one. Also between episodes, I've been keeping an eye on our storage here. Some of these are getting pretty full, so I added a couple more drives, but it's easy enough to expand this and scale this now. And yeah, remember some of the dusts from this have their own drawers already, like for example the stone dust, so not everything from here is clogging up the drives. And like we don't have any tiny dusts or anything, so I'm not really too worried about that. I also upgraded the dynamos to Signalum tier as well. And yeah, as you can see, we're currently at 8700 RF a tick on each one, with up to 12,500 headroom. So we're alright for power just now. It's just that we do need to build the reactor sooner rather than later to get our power situation sorted, at least until the late game. And then we'll look into the Greg Tech power generations, like the turbines and things like that. So yeah, this was just a quick update to the start of this video. I'm going to go and do a bunch of research for how I want to do this reactor now, because there's things like cooling and making sure we don't melt this thing down, basically, that I want to understand before I start placing things and causing a disaster here. So yeah, I'm going to figure this out and then I'll come back when we are ready to start building this thing. Alright guys, so we are back. I have built this reactor, and I want to say right off the bat, this is not going to be a tutorial. I really don't know what I'm talking about here, and 100% I just copied this reactor design. Maybe in a second playthrough or something like that I'll try tinkering with it, but yeah, even the quest mentions that it's probably wise to follow a guide or tutorial, so that's exactly what I've done. So yeah, let me show you how I understand this to work. So this reactor uses the Tbu fuel. This is what I showed earlier on. This was the stack of thermal centrifuges, which centrifuges the thorium dust. That gets stored in this drawer here to make the Tbu fuel. And then this goes inside the reactor port as Tbu fuel. And we're getting just a little bit over 200,000 RF a tick. However, you can see it's kind of blinking here, and that's because of this redstone control. This is just the same thing that's on the wiki, basically. It's just a comparator that reads the fullness of the RF here, And once it gets to above about a fifth, the reactor will turn on. It basically just inverts the signal. And when it receives the redstone signal, it will turn itself on until this reaches below a certain threshold. So you can see it's roughly 3700 RF in the stored buffer is when it turns itself on. And I believe this Tbu fuel only depletes once it, if it's running. It won't deplete if it's in this paused state. And yeah, you can see the cells, we've got 116 cells inside, and it's at negative 9872 heat per tick. And that's because I'm cooling it with cryothium. You can see molten cryothium in these buffers here. We've got 4 on each side. Well, 4 on these 2 sides, sorry. And that's being fed by this ender tank, which is coming from here. And I just have a crafter making more cryothium. That's importing it into a fluid extractor, giving us molten cryothium, which is used to cool the reactor. Basically, the only thing we have to keep an eye on is, do we have enough of this? If the answer is no, then bad things happen. But yeah, I've written in chat here, we've got 10,459 thermal pristines, and that was about 10 minutes ago. Let's check how much we have now. 10,483. So yeah, we're going up, we're positive in pristines, which is a good sign. And yeah, I'll keep checking this, but I believe we're positive on reactor coolant. We don't need to worry about that at the moment. We're also positive on TBU as well. This number's going up, which is a good sign. So we basically have a stable 200,000 RF a tick, like when the base demands it. It doesn't just spew out power and waste fuel, which is good. So yeah, and then once this fuel reaches 100%, or once it depletes, it turns into depleted fuel, depleted TBU. And this is what we're going to centrifuge to get the next tier and fuel the next reactors. So the next reactor I build is going to be another fission reactor, but this one is going to be for power. This is basically just a reactor to process the TBU. It just happens to give us power, which is really nice at this stage. However, the reactor I want to build next requires hundreds and hundreds of casings, which we don't currently have the resources for. Like, we're missing like 1,000 tungsten, something like that. We're currently at 700. We need about 1,800 tungsten for the next reactor alone. And that's not all either. We need a bunch more resources that we don't currently have. But it's nice that we have ore processing now, that we can just run some microminers and get that quite easily. Now that we have power as well, we can disable or enable the overclocks on that. And everything's going to be much, much faster now. I think I may have said 4,000 earlier on, and this is actually min million. I just realised that this unit is million RF if you look on the tooltip. It's actually 4.3 million RF, not 4.3 thousand. But yeah, as I say, I'm not going to pretend I know exactly how this works. I just pretty much follow the guide. And so if you're looking to know how this works, I'm probably not the person to ask for this. The next thing I'd like to move on to is trying to get the next tier of circuit. While we're waiting for more resources from the blast furnace and things like that, there is other things that we can do. Like, for example, the tier 6 circuits, and then Indium, Gallium, Phosphide, and also these wafers as well. We can start automating these. So I think that's something else that we're going to tackle today, actually. Let's first start by automating indium then. So just to quickly recap, we need to mix indium concentrate with aluminium dust in a chemical reactor. We have to mix that with sulfuric acid and the galena and sphalerite from our ore processing system. So we're going to need 5 chemical reactors. I made 3 already, but I miscounted the first time. And yeah, just realised we're going to do this at EV as well. So I was thinking about over here next to our cryogenic distillation towers. So I guess we'll start at the bottom of this rabbit hole. And I think we're already making sulfuric acid, but I really don't think it'll be sufficient. Right now we're making it using ethanol. Hold on a second, no we're not. We're making it using sulfur dust and water. But this is in an MV chemical reactor. I want to improve that a bit. We'll keep that where it is, but I'm going to make a separate system for sulfur. So for that, I think we need 3 chemical reactors. Actually, let's move it over 1 more block. So 3 chemical reactors. We'll have an interface supplying sulfur. So the first process is going to be sulfur plus water. Same again, but this time we're going to use configuration 2. And this will give us sulfur dioxide. And then we're going to turn that into sulfur trioxide with more oxygen. And then finally, sulfuric acid with water. So we can start off with 2 interfaces, one to supply oxygen and one to supply the sulfur dust. So our usual setup here should work, just filtering in the sulfur and filtering in the oxygen here. So fluid filter for oxygen, and then we'll have to plug it into AE2. Any second now this should start making us more sulfur dioxide. Yep, and then we can auto output this to the next one with more oxygen to make sulfur trioxide. There we go, and then this one has to get chemical reacted with water to make our sulfuric acid. So we can put a aqueous accumulator below this. This provides water, and then we can auto output this one, and we get some sulfuric acid. We'll output this to a drum with a fluid storage bus on there, something like that, and this will be high priority for sulfuric acid. Alright, so then what's the next step here? We need one more chemical reactor to combine the sulfuric acid with sphalerite and galena. So I'm just going to conduit in here from the buffer. That'll give us sulfuric acid, and then I think I'll just put another interface on top of this one. And this will be for the purified ores. Oh man, we have a lot of this already. So these will go in here. Hide that. And then we need item conduit to insert these. We'll also have to extend our power cable along here as well. Oh right, this needs limited item filter. So it'll be a stack of each in each slot. And once we take this out, it should give us galena, yep. So this makes our indium concentrate, and then we have to combine this once more with aluminium dust. So we could just use auto output now, since there's no other reason to keep this. There's only one use for it, so we don't need to buffer this for anything. And we can add aluminium and dust to this interface, and we'll filter it for the insert here. Alright, nice. Now, what do we do with these outputs now? We have to deal with lead zinc, which can be centrifuged for sulfur, lead, silver, and zinc. These three aren't super useful, but I mean, I guess we'll take it. There's nothing else we can use this for. So let's get a centrifuge. I don't know if I have an EV1 encoded. No, I'll have to go and get an EV1. And once that's finished crafting, that will go in the next slot, and then we'll output that to some drawers. So to transfer the liquid in here, I'm going to use a pump on insert, I think. And this will get the liquid in here. We're getting centrifuged dusts, and then we can auto export into our drawers. Item auto output, like that, and then we'll add some more here and here. Wait, is it 4 dusts? Yeah, I think it's 4 dusts. We need one for sulfur as well. Lock those, and we'll also have to deal with this indium. I was considering leaving it as tiny dust, since we can mix it as tiny dust, but that means we'll have to convert gallium and phosphorus into tiny just to mix it, and I think it's easier just to convert one. So I'm going to put this straight into a packager here, and we'll filter this for tiny indium. Like that, and then we'll need a circuit for this. Is it 2? No, I think it's 1. And we'll need a power cable for that as well. Yep, so that's making indium dust. And actually what I'm going to do is move this over. Actually, on second thought, we should expose the controller here. So we'll put a storage bus on this, and then put the drawer like that. That way we can put lead here, and then auto output this to the top. A space for our indium, and it can all belong in the one drawer system. So we can lock those drawers and put storage bus on there. And then we'll hook this up to our AE system. Oh, and we also have to deal with the water coming out of this as well when we centrifuge. So for that I'll just use a fluid trash can. And we can just hide that underneath and auto output there. Or actually it won't auto output, will it? I'll need a pump for that. On there, set to export. This should be running again, nice. Alright, so let's look at what we need for these qubits. So now that we have indium gallium, wait, we don't have indium gallium, we just have indium. We have to mix it with phosphorus and gallium dust. The gallium dust we have plenty of, so it's just this phosphorus now we have to deal with. So to get phosphorus, we get it from phosphate, which comes from phosphor. Hold on, I have one of these phosphor dusts in my system, but I don't know which one. Yeah, so phosphor into phosphate into phosphorus, and that's what, yeah, so we need 2 electrolyzers. Actually, it looks like even this sulfuric acid isn't quite quick enough for this to be running 100% uptime. But I don't think it's going to be much of an issue. Like, we really don't need that much indium, do we? I don't think so. I could be wrong, in which case we're going to have to redo this, but I think we should be okay. So that's our electrolyzers done. I think this time I'll use a thin interface with a conveyor on there, and we'll set that to import. That's going to give us, oh wait, that's going to give us calcium. Okay, change of plan. I'm going to send the calcium back to the ME interface, because there's a drawer here for it somewhere, and then we'll filter this so that this inserts only the phosphor. Okay, yeah, so this allows us to deal with the calcium. I'll have to hook this up as well. So then I've put a robot arm here, filtered for phosphate. That's moving it on for phosphorus. And the phosphorus is what we want here. Then we want to send this into a crafter with a limited item filter. I've just auto output this into a drawer. I forgot about the oxygen, so I'm just going to put, I'm actually just going to trash it here. It's just a lot easier than having to deal with it, and we're getting so much oxygen that I don't even know what to do with it. So if it turns out we need it, we can change this, and there's space to change it. But we'll move the crafter over 1, and then we'll filter in here. Okay, we're now getting indium gallium phosphide dust. I don't think I want to buffer too much of this, because I don't want it to eat all of the gallium and phosphorus. So I think we'll just buffer a stack at a time, and then once the system requires more, we can just take out more. Actually, why don't we move this over 1 block, and then we can fit another drawer there. There, something like that. And I've put a downgrade in our drawer as well. So next I've set up the advanced precision laser engravers. These are going to cut the wafers using the lenses into their corresponding wafers. So we've got CPU, RAM, and power IC wafers. For now we're using the glowstone doped wafers, because that's all we have access to. However, later on we can use Naquadah doped. Yeah, we can use these Naquadah doped wafers, and these give us even higher yields on the cuts. But for now, this just takes the glowstone doped wafers, which come in through the ME system. There's also going to be 2 more as well, but I can't quite make the lenses yet, and they're not relevant for the tier of circuits that we're at. I think it's for the tier 7 and above, for the next tier of lenses. So I've left space for them anyway, and we're just going to output those to drawers as well. Okay, so these are all just going to be outputted to the drawer, and the reason I'm not putting these straight into cutting machines is because things like the RAM can be split 2 ways. Or, wait, not the RAM. Yeah, these CPU wafers can either be nano CPUs or they can be central processing units. And we actually need both of them, because this is for the tier 1 circuit. And then the nano is for the qubits, and also for nano CPUs for the 4th and final tier 3s. So right now I'm just going to store them in drawers, and then we'll process them a bit later on. However, I would like to get the radon. And this is made by electrolyzing radium salt, which we get from microminers. And then I'd also like to set up processing for rock salt, because I have thousands of this, and this can give us some free chlorine and also potassium. So I think I'll just set up 2 more electrolyzers next to this. And maybe we'll do it on the other side actually. Yeah, we'll do it here instead. So we've got our 2 electrolyzers here. This is auto outputting radon into this one. And this is auto outputting chlorine into this buffer here. And then we have to put potassium away, so I'll put a drawer for that as well. And we'll also attach some fluid storage buses to these 2 drums here. And we can also put a storage bus on our drawer here for the potassium. And I think we're done here. This chlorine is all going to get eaten by these systems over here. Yeah, this demands so much chlorine. But that's good, that means we're making boards and wafers. Everything we need for circuits. Yeah, these machines are on now. Which is a good sign, where it means we're buffering some circuit boards. Alright, let me show you what else I got set up here. So I think I was up to here last time. It's now the next day, so yeah, I set this up last night. I just decided to go up ahead and finish it, but I'll show you how it works. So this fluid extractor combo here, it gives us molten glowstone. Used to be over here. It was tucked away in this corner. I've decided to move it just to keep all the wafer things beside each other. So this gives us molten glowstone, which is combined with raw carbon fibers. And then this is combined to make nano CPUs, and this is put in this drawer here. Then this one is taking our radon and combining it with indium gallium phosphide and the nano CPUs as well. And then this outputs qubits, and the interface supplies both the wafer and the indium gallium phosphide. And then these level limiters control how much to stock. So right now I'm stocking 256 of the qubits. And similarly, this controls the nano CPUs. I just have these extracts on the imports of the chemical reactor set to active without signal. Although I'm not really sure why this is 256 and we have 997 in the drawer. I think it might just be extra that I had crafted before I set this up. I'll look into that a bit more. But yeah, the next one is for power IC wafers. So the power IC is being cut here, and then we're importing that into this chemical reactor. That gets combined with red alloy and more indium gallium phosphide to make our high power IC wafers, and that's getting stored in this drawer here. And then all these wafers, I have processing patterns just on demand in our cutting machine array. I'll show you that as well. Yeah, you can see here all of these wafers get cut on demand into their various like CPUs, the high power ICs, RAM, qubits, and central processing units. And also, just as a quick project last night, I found myself out of rubber rings for pumps. If we look here for the uses for these things, these all make a couple of pumps up to IV tier. The way I was getting these before was just manually crafting them by hand. However, I've set up this system for rubber. So this just extracts all of our rubber that we get from our tree farm. We have like hundreds of thousands of this. And that gives us raw rubber pulp. And then we chemical react out the sulfur to give us rubber liquid, just a regular rubber. And then that's split between these two fluidic solidifiers. One gives us rubber sheets, which is used for conveyors. And then one solidifies it into rubber bars, which is passed to this extruder to give us rubber rings. So that was just a quick little setup. I just made it MV/HV, since it doesn't need to be quick and we get so many of these. And I thought it was just worth automating rather than keep crafting them by hand, so I don't have to worry about that again. But yeah, with that, I think this is about time to wrap up this episode. We got a lot of things done today. I'm really happy I built that reactor. There's a couple more still to be built. And yeah, we got our CPU situation sorted out. The only thing that's left to add to this particular system is the SOCs and ASOCs. And this is like even cheaper circuits and higher yield. But this is ZPM, so it's going to be a little while, but it's not too difficult to expand this now that we have this set up. So yeah, that's going to do it for today. Thank you again for watching. And yeah, I'll see you tomorrow for some more Omnifactory.